Welcome back to the channel. Today, we are uncovering the secrets behind a mind-blowing mega-build that shocked the entire world with its colossal scale. Imagine pouring enough concrete to fill 640 Olympic-sized swimming pools, and doing it in a desert against a deadline the entire world was watching. That is not a hypothetical. That is exactly what happened on the southern outskirts of Beijing, China, between 2014 and 2019, when an army of 40,000 construction workers descended on a patch of flat, unforgiving land and proceeded to build something so enormous, so geometrically perfect, and so technically complex that engineers from every corner of the planet flew in simply to stand at its edge and stare. 1.6 million cubic meters of concrete, 700,000 tons of steel, a terminal so vast that the entire footprint of Heathrow's Terminal 5 could fit inside it 4 times over. This is the story of Beijing Daxing International Airport, and the sheer, almost incomprehensible scale of human willpower it took to make it real. To understand why China decided to build what would become the largest airport terminal on Earth, you have to understand the problem it was trying to solve. Beijing Capital International Airport, the city's original gateway to the world, had been expanded twice, received a brand new Terminal 3 in 2008, and by the early 2010s was still suffocating. By 2013, it was handling over 83 million passengers a year, making it the second busiest airport on the planet, and it was running at 105% of its designed capacity. Aircraft were circling and holding patterns for 40 minutes before landing. Passengers were missing connections. Cargo was backing up. Airlines were turning down new routes because the infrastructure simply could not absorb more traffic. Beijing, the political and cultural capital of the most populous nation on Earth, was being bottlenecked by its own success. Something radical had to be done, and China's answer, as it so often is, was to build something the world had never seen before. The site chosen for the new airport was located 46 kilometers south of central Beijing in the Daxing district, straddling the border between the capital and the neighboring Hebei province. It was on the surface an ideal location, flat, relatively unpopulated, and connected to a rapidly expanding national high-speed rail network. But the challenges lurking beneath that flat surface were anything but simple. The land sat above a complex web of geological fault lines. The water table in the region was unpredictable and variable. Hundreds of villages had to be carefully and methodically relocated, displacing tens of thousands of residents before a single foundation pile could be driven. And then there was the sheer ambiguity of scale. Nobody had ever attempted to design and construct a single airport terminal of this size in one continuous build phase. Most mega airports around the world had grown organically over decades. Daxing would have to spring fully formed from the ground up, on a government-mandated timeline of just 5 years. The architectural contract was awarded to the legendary firm Zaha Hadid Architects, and the moment the first concept renders were released, the engineering world collectively held its breath. The terminal was designed in the shape of a vast, sweeping starfish, or more precisely, a phoenix with outstretched wings, a design deeply symbolic in Chinese culture representing the rise and transformation of a nation. 5 curved concourses radiated outward from a single central hub, creating a structure that measured 1.7 kilometers from tip to tip at its widest point. The roof alone covered 700,000 square meters, the equivalent of almost 100 international football pitches joined seamlessly together. And that roof was not a simple flat structure. It was a flowing, undulating form punctuated by 144 massive skylight columns that funneled natural daylight deep into the heart of the terminal below, reducing the need for artificial lighting and dramatically cutting long-term energy costs. Every single one of those skylights was uniquely shaped. There were no 2 identical structural elements anywhere in the entire roof system. To realize this vision in concrete and steel, Chinese engineers and their international partners faced a problem that had no established precedent. The central hub of the terminal required a column-free open space large enough that no passenger standing anywhere within it would be more than 600 meters from their departure gate. That meant the roof had to span extraordinary distances without intermediate support pillars. Pillars that would have blocked sight lines, interrupted passenger flow, and destroyed the architectural coherence of the design. The solution was a diagrid structural system, a diamond-shaped lattice of interconnected steel beams that distributed loads laterally across the entire roof rather than concentrating them at vertical points. Over 60,000 tons of steel were fabricated specifically for this diagrid, with individual beam sections arriving at the construction site from foundries across 5 Chinese provinces. Fitting those beams together to tolerances of less than 2 millimeters across a structure nearly 2 kilometers wide required a level of precision that pushed the limits of what conventional surveying technology could achieve. Engineers deployed a custom 3-dimensional laser positioning system, originally developed for shipbuilding, and adapted it to track the exact coordinates of every structural node in real time as the steel was being welded into place. Below ground, the engineering challenge was equally staggering. The airport was designed from the outset to integrate directly with China's high-speed rail network, meaning that active railway tunnels had to be threaded through the terminal's foundations, while construction of the building above was simultaneously underway. Two high-speed rail lines and one intercity rail line now pass directly beneath the terminal concourse at depths of between 15 and 30 meters. The tunnels were bored and lined before the superstructure rose above them, but the foundations supporting the terminal had to be engineered to transmit the enormous loads of the building down through the soil without ever allowing that load to transfer onto the tunnel linings beneath. This was achieved through a system of deep reinforced concrete piles, some driven to depths of over 40 meters, arranged in carefully calculated clusters that essentially created a bridge above the tunnels while appearing, from above, simply to be a building standing on solid ground. The concrete operation alone was a logistical masterpiece of military-like coordination. At the peak of construction in 2016 and 2017, over 45,000 workers were on site simultaneously, working in rotating shifts around the clock 7 days a week, 365 days a year. Concrete was being poured at a rate of 15,000 cubic meters per day, enough to fill a standard shipping container every single minute. The site operated its own dedicated concrete batching plants, its own internal road network, its own workers' townships with canteens, dormitories, and medical facilities. It was, in effect, a temporary city erected for the sole purpose of building a permanent one. The logistics of feeding, housing, and medically supporting 45,000 workers while simultaneously managing the delivery of millions of tons of raw materials across a single congested site pushed Chinese construction management to levels of organizational complexity that project managers later described as closer to running a military campaign than a building site. As the structure rose through 2017 and into 2018, the interior fit-out began introducing a new layer of complexity. The passenger experience at Daxing was designed to be unlike anything in the world. The central hub was conceived as a self-contained city within a city, featuring over 100 retail outlets, dozens of restaurants, a hotel, a medical center, and an integrated indoor garden spanning multiple levels. The wayfinding system had to guide passengers speaking dozens of different languages through a structure so large that conventional signage alone was considered inadequate. Instead, the airport deployed an AI-powered digital wayfinding network with thousands of interactive terminals and ceiling-mounted projection points that could communicate in 12 languages and update itself in real time as gate assignments and flight statuses changed. The runways and airfield infrastructure matched the terminal's ambition. Daxing was built with 4 runways on opening, with land reserved and foundations pre-engineered for an eventual 7. The runway layout was configured in a split parallel arrangement, a design used nowhere else in the world at this scale, that allowed aircraft to land and take off simultaneously on multiple runways, with no conflicting flight paths, dramatically increasing the theoretical maximum number of aircraft movements per hour. The air traffic control tower, at a height of 99.9 meters, was purpose-built to provide unobstructed sightlines across all 4 runways simultaneously, a feat of sightline engineering that required the tower's observation cab to be offset from its central structural core by 20 meters in a cantilevered design that gave it the appearance, from a distance, of a vast leaning monolith watching over the plains. On September 25, 2019, exactly on the date Chinese authorities had publicly committed to 5 years earlier, Beijing Daxing International Airport opened its doors to the world. The first commercial flights departed that morning, and within the terminal, 82 moving walkways, 28 security lanes, and 400 check-in desks processed the first passengers with an efficiency that left international aviation observers genuinely stunned. The airport is designed to eventually handle 130 million passengers per year, making it capable, at full capacity, of processing more people annually than the entire population of Mexico. It is not merely an airport. It is the physical embodiment of a national ambition, the declaration of a civilization that has decided it will not be constrained by what others consider possible. The story of Daxing is a story about what happens when a government, an architect, an army of engineers, and 45,000 workers all decide simultaneously that impossible is simply a word used by people who have not yet worked out the details. 1.6 million cubic meters of concrete poured across a desert floor, shaped by human hands into something that will carry the hopes, the commerce, and the dreams of hundreds of millions of people for generations to come. If you found this story as extraordinary as the airport itself, take a second right now to hit that like button. It genuinely helps us bring stories like this one to more people around the world. And subscribe so you never miss the next chapter in the long, extraordinary history of things humanity was never supposed to be able to build.
Attention.
Keep them moving. Fast, fast. Keep feeding.
Check system status. Bags diverting to gate 7.
Welcome. Thank you for participating.
Ticket and passport, please.
You can use kiosk number 3.
The certificate is now officially approved.
Thank you, sir.
May this airport serve its people with distinction.
Testing completed. The doors are functioning perfectly. Excellent. Let's finish up here.
Attention all passengers, please proceed to gates listed on screens. Final boarding call for flight 712 to London.
It's perfect. Exactly how we drew it up.
This video is created for educational and informational purpose using advanced AI tools and human creativity. All concepts, scripting and storytelling are independently developed to ensure originality. Visuals and animations are generated or enhanced using AI technologies such as VEO, Canva and Grok AI, while final editing and post-production are completed using CapCut and other professional editing tools. No external creator content has been copied or reused. Any resemblance to real-world environments, factories or process is purely coincidental. All scenes shown in this video are digitally created and do not represent real footage. This content is produced with transparency and follows YouTube monetization guidelines.